So here we are with 2.4, day 2. So you can just keep going on the same set of notes as you were before. You don't have to start a whole new thing. But today we're going to talk about all, one, or no solutions because sometimes some strange things happen. So would you please write what you see inside this box? Linear equations do not always have one solution. An identity, let's see if I can write that smaller. Identity is an equation that is true for all values of the variable. Some equations have no solution, meaning no solution will make it true. So every equation will have one solution, all solutions, or no solutions. So the way we will denote that, if it's got one solution, you just write the answer. This right here, all solutions, we're going to make this little symbol, we call it the double bar R. And the double bar R stands for all reals. And this is something I was checking in with Ms. McDonald today. How do you say this in Algebra 2? And they will do this little double bar R if all of the answers, if all real numbers work. And sometimes you'll have no solution. So we're going to go through, and what I want you to do is just go through these problems right here. So there's 4, and you will find out that some funny things happen. Sometimes you just can't do things. Sometimes you can't do things another way, and sometimes you'll just get an answer. So come back to me in a couple of minutes and we'll see what happens. Okay, so here we are back at all of the answers. So the first one I went through and distributed over here. Then I put these two together. So I got 4 minus 1x equals negative 2x minus 2. I chose to move this 2x over here so that I would have a positive x. This could have moved over here. I just, personal opinion, like positive x is better. Drop down my 4, subtract 4 from both sides, so x equals negative 6. So this one, because it's got one solution, we're just going to say that it has one solution. So I can just say one solution. I'm going to abbreviate that at one sol. But then you come over to number 2, and something funny happened. I got 2 times 3x, I got 6x plus 8. And then here I got 6x plus 9, and did you see that you can't do that? Like, if I put in 0 here, 6 times 0 is 0 plus 8. 6 times 0, 8 doesn't equal 9. So you cannot do that. So that one is a no solution because it can't be done. Can't do it. All right. Now look at this one. When I did this one, I got negative 1x plus 3. And over here I had 3 minus x. So I chose to change this order a little bit. And look at, this is negative 1x plus 3. This side is negative 1x plus 3. Well, gosh, now I notice that they're the same. So that means the answer for this one is all reals, or any number that you put in would work. If I put in 1, negative 1 times 1 plus 3, that gives me 2. Negative 1 times 1 plus 3 is negative 2. Any number I put in for x will work on this one. This one, nothing that I do. If I had gone, if you hadn't noticed that it was no solution, I could have done this. I could have subtracted the 6x from both sides, but then I would have gotten 8 equals 9, and 8 does not equal 9. You can't do it, so it's still no solution. This one, I got y equals 5. Did you? Here's how I did it. Right here, negative, negative. And you say, no, it's a minus. And I say, same thing. So this just flips the signs on everything inside. So 6y minus 3y. Did you get that? And plus 6x. So the signs, just be careful of the signs so they don't get you every time. There you go. 5y minus 5. I put these two together and got 3y. Still adding the 6. 5y minus 4. I chose to subtract 3 y's from both sides. I could have subtracted 5 y's. However, that would give me negatives, and I just don't want negatives. Doesn't make it wrong, just makes it a little more difficult in my opinion. Drop down my 6, 2y minus 4, so I choose to add 4 to both sides. I get 10 equals 2y, and so therefore y equals 5. So this is one solution again. So one solution, no solutions, or all reals. I'm going to have you try 3 more, and then so you push pause, try them, and then if you're struggling to go through and solve them, I will walk through them with you this time, and then if you don't want to listen, just fast forward. Actually, maybe I'll put the answers out, and then I'll give the explanations after that. All right, see you in a minute. All right, so as you went through them, for number 5, you should have gotten x equals -2, so that's one solution. Number 16, you got no solution. Or number 6, you got no solution, sorry. And number 7, you got the double bar R for all reals. So if you totally got that and you're like, I'm done with this, you may stop. If you did not get those and you need to go through an explanation or two, then keep watching and I'll walk through them now. So this first one, I've got 9 x's on this side, plus 24, and then -3 x's. And I was going to move the 24 right away until I noticed that there's an x here, x here. So just because there's x's alone over here, in this case, I'm going to choose to subtract 9x from both sides. Now, could I move this 3x over to here so you'd have positive 12 x's? You could, but it would make you longer because you'd have to get the 24 over here. So you might as well just go this way. And so I drop down my 24 equals -12x. And how do I undo that? -12 times x. Got it. -12. Divide by -12. And so 24 divided by -12 is -2. But Mrs. Beaver, you wrote it on the wrong side. Good point. It doesn't matter. As long as you get the x on one side and the -2 on the other. And we've got one solution. This one over here, it's no solution. Well, why? Well, I'm going to distribute, so hopefully you're getting pretty darn good at the distributive property so far. So -3 times 2x is -6x, and -3 times -5, yes, that's negative, plus 15. Over here, -15 minus 6x. All right, do you notice something? Yes. Yet. I do. I notice there's a -6 over here and there's a -6 over here. That's problematic because this is positive 15, this is -15. I had to check my work several times. Yes, one's positive, one's negative. If that is the case, then my -6's, since they're on both sides, I could, if I wanted to, add 6 to x to both sides. So plus 6x plus 6x. Look at that, cancels out there, cancels out there. So I get 15 equals -15. That is not true because either you have $15 or you owe $15. Not the same thing. This is a debt. This is to the good. So since they're not equal, it's no solution. And the last one, the reasons it's all reals, I'm going to put these guys together. So combine like terms first. 2s minus 5s gives me -3 s's. Keep my plus 11. Over here, let's put this 2 and the 9 together. So I've got -3s plus 11. Do you notice something? Exactly the same. The -3s is the same, and the 11, they're both plus 11s, plus 11s. That means no matter what I put in for s, it will work. So that's your double bar R for all reals. Any number you put in here is going to work. So hopefully these are getting better. That's why we're doing a video, so you can kind of chew on it a little bit, and we'll come back to class and do some more tomorrow. Have a great night.